problem that we might come across for a displacement time graph. So I'll walk you through how to approach it. The question is, the graphs show the positions of the same wave 0.5 seconds apart. Analyse them to calculate the maximum possible period for the wave. Okay, so this is what I do. I look at my wave and I try and find one cycle. So this is my one cycle here, and I find a point where I can see where it might be 0.5 seconds later. So it's going in this direction, and I find that if I colour in an area here, I can easily, locate it where it's moved to. So I do this, and then I go back and I say, okay, well, it's gone this far. Okay, so then I've got this much, and I can see by looking at it, it's not a full cycle that it's moved, it's only moved. And if I sort of trace where that might be, that would be one full cycle, but it's only gone 3/4. Okay, so I just annotate it and put quarter areas in, so it's easy to see, because sometimes it might actually, you might find that it might be 1/8 of a cycle movement, for example. Okay, so I know it's gone 3/4 of a cycle. It's moved 3/4 of a cycle. All right, I'll just write that in, and I may as well do it over the time. So in 0.5 seconds. Okay, so this is how we calculate the frequency. So frequency, if you remember, is cycles per second. So I do my calculation. So here we go. The wave has travelled 3/4 of a cycle in 0.5 seconds. So I set up my my response, which I can identify that. I can use that to calculate my frequency, which is cycles per second. So 3/4 is 0.75 of a cycle, and my the time it took is 0.5 seconds. So I find here that the frequency is 1.5 per seconds or hertz. Okay, so remember from our relationships that one period or t equals 1 over the frequency. Okay, so 1 over the frequency, so our frequency is 1.5, so 1 over 1.5 gives us 0.67 seconds. So the period of the wave is 0.67 seconds.